Distance formula. Let us now find the distance between 2 points P with coordinates x1, y1 and Q with coordinates x2, y2. At first, we make perpendiculars PM and QN on OX and we make a perpendicular on QN from point P meeting at point R as shown. Now this picture gives us the equivalent of x1 as OM and we will get y1 equal to PM, which is equal to Rn. In addition to this, the equivalent of ON is x2 and QN is equal to y2. Hence, PR is equal to MN, which is equal to ON minus OM, which is equal to x2 minus x1, and QR is equal to QN minus RN, which is equal to y2 minus y1. Therefore, by Pythagoras theorem, we can say that PQ square is equal to PR square plus QR square, that is, PQ square is equal to x2 minus x1 square plus y2 minus y1 square. Hence, PQ is equal to the square root of x2 minus x1 square plus y2 minus y1 square, which is known as the distance formula. Or if x1 and y1 are equal to 0 and x2 and y2 are equal to x and y, then PQ is equal to the square root of x square plus square root y square. Come on, let us understand this better with the help of an example. Example. Show that points A 5, 6, B 1, 5, C 2, 1 and D 6, 2 are the corners of a square. Solution. Come on, let us use the distance formula to find the distance between AB, BC, CD and DA, where A 5, 6, B 1, 5, C 2, 1 and D 6, 2 are the given points. So we have the formula PQ is equal to square root of x2 minus x1 square plus y2 minus y1 square. At first, we find the distance between the points A 5, 6 and B 1, 5. This means AB is equal to square root of 1 minus 5 square plus 5 minus 6 square is equal to square root of minus 4 square plus minus 1 square is equal to square root of 16 plus 1, that is square root of 17 units. Now, the distance between B 1, 5 and C 2, 1, which means BC, is equal to square root of 2 minus 1 square plus 1 minus 5 square, which is equal to square root of 1 square plus minus 4 square, which is equal to square root of 1 plus 16, that is square root of 17 units. The distance between C 2, 1 and D 6, 2, which means CD is equal to square root of 6 minus 2 square plus 2 minus 1 square is equal to square root of 4 square plus 1 square is equal to square root of 1 plus 16 square root of 17 units. The distance between D 6, 2 and A 5, 6, this means DA is equal to square root of 5 minus 6 square plus 6 minus 2 square is equal to square root of minus 1 square plus 4 square is equal to square root of 1 plus 16 square is equal to square root of 17 units. The distance between points A, 5, 6 and C, 2, 1. This means AC is equal to square root of 2 minus 5 square plus 1 minus 6 square is equal to square root of minus 3 square plus minus 5 square is equal to square root of 9 plus 25 is equal to square root of 34 units. The distance between B, 1, 5 and D, 6, 2, this means BD is equal to square root of 6 minus 1 square plus 2 minus 5 square is equal to square root of 5 square plus minus 3 square is equal to square root of 25 plus 9 is equal to square root of 34 units. Because AB is equal to BC is equal to CD is equal to DA is equal to square root of 17 units and AC is equal to BD is equal to square root of 34 units, all the four sides of quadrilateral ABCD are of equal length and its hypotenuse AC and BD are also of equal length. Therefore, ABCD is a square.